Find the area under parabola y square equal to 4x above x-axis and between x equal to 0 and x equal to 3. Now here if you observe the parabola y square equal to 4x is a standard parabola, so we know that it has the vertex at origin, so it looks like this, correct? And we have to find the area below parabola between the limits x equal to 0 and x equal to 3, correct? So the area that we want to actually calculate is this particular shaded area. So to get that area, let us consider the thin vertical strip. So this is a thin vertical strip and it has the width of dx and the length or the height as y. Now the required area is given by integration of areas of all such thin strips, correct? So that is integral of dA. Now here the variable is x because x is varying from 0 to 3. So therefore we must integrate it from 0 to 3. Now here dA can be written as y dx as we have seen earlier, because for the thin strip length is y and the width is dx. Limits are 0 to 3. Now we will have to express y in terms of x because the variable of integration is x. Now since we are given that y square is equal to 4x, so therefore y is nothing but 2 root x, correct? And to be integrated from 0 to 3. Now this is straightforward to integrate. Let's take 2 outside, and root x is nothing but x raised to half, right? So therefore integral of x raised to half will be x raised to half plus 1, that is x raised to 3 by 2 upon 3 by 2 from 0 to 3, which equals, bringing 3 by 2 above, we have 4 by 3, and now in x raised to 3 by 2 we'll have to substitute upper limit, that gives us 3 raised to 3 by 2 minus 0 raised to 3 by 2 is nothing but 0. So that gives us 4 by 3 into 3 raised to 3 by 2 is nothing but 3 root 3. So cancelling 3, we finally get the answer as 4 root 3, which is the required area. Now let's solve another question. Now here we have to find the area between parabola y square equal to 4x and y axis between y equal to 0 and 4. So once again, if you see, we are given the same parabola as in previous question, but now the area asked is different. Now it is between the parabola and y axis, between two limits. So that is y equal to 0 and y equal to 4. So the area that we are asked is as shown here in green shading. Right. So to calculate this area, we will see that now it's more convenient to consider a horizontal strip rather than a vertical strip. Right. So this strip is of width dy and it's of length x, isn't it? So the required area is the integration of all such areas, these areas of all the infinitely many horizontal strips. Now that is further equal to the area of one strip is x into dy. So you see here is the y, which is variable of integration, and y varies from 0 to 4, which is given to us. So now we will have to express x in terms of y. So looking at the equation of parabola, since y square is 4x, so therefore x is nothing but y square by 4 dy. The limits are 0 to 4. So once again, taking 1 by 4 outside, integral of y square turns out to be y cube upon 3 as we know, and integrated from 0 to 4. So taking out 1 by 3, we have 1 by 12 outside, and now putting y as 4, which is the upper limit, we have 4 cube is 64 minus putting y as lower limit 0, we have 0 cube as 0. So therefore finally we have the answer as 64 by 12. So we can cancel out a factor of 4 and finally get 16 by 3 as the answer. Right? So in this way we can use the horizontal step to calculate the area. Now let's see another different type of question. Using definite integrals show that the area of a circle having radius r is pi r square. Now we are already aware from school time that the area of circle is pi r square. We had taken that result for granted but had not proved it. So here is, let us see how we can prove that the area is pi r square using definite integrals. Now to do that, let us consider a standard circle. That is a circle in standard position, that is it is having its center at origin. So it is symmetrically located in all the 4 quadrants. So if you observe the 1/4 of the circle which is present in the first quadrant, okay, it is having the area exactly 1/4 of the total area of the circle. So therefore if we just find out this particular green shaded area and multiply it by 4, we will get the area of the circle. So it is sufficient to calculate only this shaded area. Now to calculate that, we follow the similar procedure as we have seen earlier. Let's consider some vertical strip, okay, of width dx and height as y. Now our total area is 4 times area of 1/4. Correct? Now for the limits, if we see that x varies from 0 to r, right, because that is the maximum value that x can take, which is the radius. So here we have y dx and x varies from 0 to r. Now here remember, although r is a symbol, it is not a variable. Okay, it is called as an arbitrary constant simply because for a given circle the radius will always be constant. So we just don't know what that value is for our example, therefore we denote it by a letter r. But remember, it's not a variable here. Now the next task is we have to write y in terms of x. Right? For that, if you observe, they have not given the equation as such, but we know what is the equation of a standard circle, and that is nothing but x square plus y square is equal to r square. Correct? That's the equation of a standard circle. So therefore based on this we get y as nothing but square root of r square minus x square. Correct? So therefore our area turns out to be 4 into integral root of r square minus x square dx and integrated between the limits 0 to r. This is equal to. Now if you observe, the given integral is of the form root of constant square minus variable square. So we know that this is a standard result in integration as we have seen earlier, and its integral is given by this particular formula. We have the first term as x by 2 multiplied by the same square root expression that we have. So that is root of r square minus x square, which is the first term. Then you have plus constant square upon 2, so which is nothing but r square upon 2 in our example. And since it is of the type root of constant square minus variable square, the remaining part is the sine inverse of variable upon constant. So that is, let us write it as sine inverse of variable upon constant. That is x by r. Now we have to evaluate this entire integral between the limits 0 and r. Now let us first substitute the upper limit. So when we put the upper limit, if you observe, the first term has r square minus x square, correct? So therefore when we put x as r, that particular expression will vanish and it will become 0. Now moving ahead, the second term is r square upon 2, so that remains as it is, which is r square upon 2 into sine inverse of x upon r. So when you put x as r, we will get r upon r as 1. So therefore sine inverse of 1 is nothing but pi by 2, which is 90 degrees. So therefore let us write it as pi by 2. Correct? So this is the expression that we get after putting the upper limit. Now from it we have to subtract the expression that we get by putting lower limit. Now if we see, when we put x as 0, the first term becomes 0 simply because we have x by 2 as one of the factor in the first term. And in the second term, if you observe, we have sine inverse of x upon r. So if we put x as 0, x upon r gives us 0, and hence sine inverse of 0 is nothing but 0. So therefore by putting x as 0, the entire expression becomes 0 only. So for solving further, if we open the bracket, we will see that 4 will get cancelled out, and hence therefore we are left with pi r square as the remaining expression. So therefore we have proven that the area of the circle with radius r is equal to pi r square with the help of definite integration approach.